Hello students. So today we will look in a new topic that is called inverse function. So before starting this topic, I recommend everyone to check out my other videos on composite function and the function as well, which you will get by clicking in the I button over mentioned here. Okay. Now in this video we will be looking at the inverse element, and then we will come to inverse function, and then we will see that for a function to exist as invertible, it is mandatory for that function to be a bijective. And we will see a property for g of f, that is, this is a composite function we have discussed in the previous lecture. And another thing is that we will solve two or three problems which will contain some of the topics here, inverse element and the inverse function. We will find some inverse function of these two functions. One is exponential function and another is a cubic function. Okay, so suppose we are having a function y is equal to f of x. Okay, so this is a function, right? Now let's say f is such a function that maps from two sets, 1, 2, 3. This is the domain set, and it maps to a set which is A, B, C, right? These two sets, this is the domain set and this is the codomain set for the function f, right? Now let's draw a diagram regarding this. Suppose this set we name it by x and this one by y, right? Now in the x set we have the elements 1, 2, 3, and in the y set we have the elements A, B, C. Okay. Now suppose it maps in such a way that 1 maps to A, 2 maps to B, 3 maps to C. This is the function f. Now from the definition of the function itself, we can easily write that f of 1 equal to A. Obviously it is, we can plug in this value from this diagram. Now accordingly we can write f of 2 is equal to B, f of 3 is equals to C, right? Now where the question of inverse element comes from. Okay, suppose if there is another function, let us consider another function g, right, which maps from y to x. That is, in the previous case the f was mapping from x to y, and in this case g is mapping from y to x. Okay, so this is quite inverse, right? Here A maps to 1, B maps to 2, C maps to 3. An interesting thing is that g of A is 1 and g of B is 2, g of C is 3. Now by looking at these 6 function element image and pre-images, we can conclude that if you inverse these things, that is, if you have been asked this question that what is the inverse of this element A, f of A, suppose f inverse of A, that means you have been asked a question to write the pre-image of this value within the function f. So you have to check within the function f. Where is the function f? Here. So within this function, what is the pre-image of A? A is an image of something, right? So what is the pre-image? 1. So that is f inverse of A will give you 1, obviously. In this way, you can write f inverse of B is equal to C, f inverse of B is equal to 2, f inverse of C is equal to 3. So we can see that the images and the pre-images of the function g and the function of f inverse are similar. So from this condition we can say that f inverse of x will be equal to g of x, right? So inverse element is that you will be asked the inverse element of some function. Then actually you have been asked the question to find out the pre-image of that element within that function. Okay, now we will come to the definition of inverse function from these stuffs. Here let us write the definition of the inverse function from this relation. Okay, now you can note down this relation by having a screenshot or pause the video, because I'm going to rub it and then we will describe about the definition of inverse function. Suppose f maps from A to B. Okay, it is such a function such that f of x is y. Here x belongs to A and y belongs to B. B is obviously the codomain and A is the domain. Now, if there exists a function g, okay? Now, if g is a function that is existing, then obviously it will have its domain and codomain. Now, what will be its domain? Its domain will be B. G is mapping from B to A, which means that the domain of this function f is the codomain of this function g, and the codomain of this function f is the domain of this function g. Here, such that if these types of function exist, right, then we can say that if f of g will be identity function. Now, on what domain it is identity? This thing you need to note down. See, look at this. This is f of g, right? So f of g of what? Notice, here I will put an element which belongs to the domain of g, not the domain of f. Now what is the domain of g? B, right? So here an element, suppose that this element is y. As I have written here, y belongs to B. Suppose this element y belongs to B. Okay? Then we will get an identity function of B. Identity function over the set B. Just remember, if you write here I of A, then it is wrong, because A is the domain of F, not G. Okay? So this thing will be f of g is equal to I of B. And the commutative one, that is g of f, should be this one. Now if these conditions exist, then we can say that g will be f inverse. Right? Now another thing is that in case f inverse exists for any function, in case f inverse exists for any function, then f is obviously bijection. Bijections means bijective function, or you can call it 1-1-1-2 mapping, right? Okay, so we are done with the inverse element, we are done with the inverse function, we are done with the inverse function is always a bijective mapping. Now we will see another property. notice this property is very essential, right? You will get this property whenever you will solve some problems in the JEE mains or in your board examinations, because this property related problems several times it appears in your JEE mains or in other exams. Suppose F and G are 2, 1, 1 on 2 mapping, right? Suppose F and G are 2, 1, 1 on 2 mapping. Okay, fine. They can be 1, 1 on 2 mapping. Then we know G of F is also bijective, right? Is also bijective, or bijective you can say this 1, 1 on 2 mapping. Okay. Then this thing we have studied from the properties of the composite functions. Okay. Now the thing that separates this formula from the previous one is that G of F inverse is also one on 2. Now this thing, students, keep in mind that G of F inverse is also 1 on 2. This is not like that only G of F. If you write F of G, then it is also true in that case. Now we are having a formula. G of F inverse is equal to F inverse of G of inverse. Now note this formula down by pausing the video so that you can apply this formula whenever you are solving this problem. If you guys want the proof of this formula, then obviously we can prove it in another video. But for that thing, you should do your sums properly, and you should mention that you are facing some problems here and you don't understand this formula. Now we will look at some problems. Over 3 problems are noted down here. So we'll look at these problems. Okay. Given, the thing that is given is F maps from Z to Z, right? Integer to integer. Fine, we have no problem. And it is defined by F of X is equal to X square. This is defined. F of X is equal to X square. This is defined. Fine, that's fine. Now what's the question? The question is find F of 4. Fine. And find F inverse of 4 and F inverse of minus 2. Now, the thing is, look at the thing, that Z is the codomain and this Z is a domain also. Z means the integer. Now this integer set Z consists of the positive integer 0 and the negative integer as well. Okay, this Z, right? If I draw a diagram over here, suppose these are 2 Z and this is containing sum from minus infinity to dot 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 minus 2, minus 1, 0, plus 1, 2, 3, dot 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 up to infinity. And from here also the same case is happening. Right? Now the question is, we have to find the F inverse of 4. For that thing, we need to find for what thing this F of X is equal to 4. We need to find this thing, right? This F of X is equal to 4. Now let's say f inverse of 4 is equal to A, right? Now from this line we can write this implies 4 is equal to f of A, right? Again we can write this, if I come to the left hand side, then A square will be equal to 4. Now what it will give? It will give A is equal to plus minus 2, which means that this element is having two pre-images, right? This element is having two pre-images, and those images are plus 2 and minus 2. Now in the second case, where it has been asked to find f inverse of minus 4. Now notice that this minus 4, the domain of this minus 4, I mean the set of this minus 4 is nothing but the codomain of this set f. The codomain of this set f is defined by this x square. Whatever term is there is the perfect square. Now no perfect square in the universe. If the x is real number, then x square is not negative. This is positive. If this is positive, then the range of f is z plus, which means that the positive integers, right? So this set z plus does not even contain this element minus 4. Now where it will get any pre-image, right? So that's why we will have a null set over here, right? Now let's come to the solution of the next problem, this one. Okay, so in this problem we are given a function f maps from real number to real number, and f of x is defined as x cubed plus 1, and we need to find f inverse of x. Right? Note down the steps we follow in this problem. To solve this problem, we will follow some definite number of steps, and I request all my viewers to note down my steps, because these are the steps which you will apply in solving such types of problems, and these will appear in your exam form. First of all, for a function, when you are going to find out the inverse of that function, you need to prove that this function is a bijective function, which means this function is a 1-1 and on-to function, right? Step 1. So step 1 is f is 1-1 on-to, right? And then find f inverse. Now in finding f inverse, we will write x in terms of y, then we will write f inverse of x. Note down these steps which we will follow during we solve this problem. Here we have been given f of x is equal to x cubed plus 1, right? Now the first step is to prove that this function f of x is 1-1 function, right? Here, look at this direction. We have to prove that this function is 1-1 function. Now, to prove that this function is 1-1 function, let x, y are such two elements that they belong to R. Now this is which R? This R or this R? Which R? We need to find it. This R is domain R. Domain R. Okay? Domain. We have chosen this x and y such that f of x will be equal to f of y. Okay, if we have taken let, or you can say this is suppose, right? Now you have to recapitulate my last to last video, when we have found out the necessary condition for a function to be 1, 1, in which we have found out that if f of x is equal to f of y, this implies that x is also equal to y, which means that this f of x and f of y are nothing but the images of this x and y. Now if I equate these images, then obviously when I will get the pre-images to be equal, then this function is nothing but a 1, 1 function. Accordingly, if you write f of x, that will be x cubed plus 1 is equal to y cubed plus 1, and this will imply x equal to y, right? Now since f of x is equal to f of y implies x is equal to y, then f is 1, 1 function. F is 1, 1 function. Now up to this step, I urge all of you to pause the video and note it down, because I'm going to rub it and then I will find out if f is either 1 on 2 or not, right? Now the next step. Now that we have proved that f is 1, 1, now we have to prove if f is onto function. For a function to be onto, the necessary condition is that all the elements of the codomain set should have pre-images on the domain set, right? Now, this is given us like this. Now we know y is equal to f of x, where y is an element in its range and x is an element in its domain. Domain means this one and codomain means this one, right? Now say, you should mention here that y belongs to R, and in bracket you should write that this y belongs to the codomain R, not the previous one, right? So we can write that y is equal to x cubed plus 1. Now this will imply, if I convert this y is in terms of x. Now if I convert this x in terms of y, this will be nothing but y minus 1 to the 1 by 3, right? Now we have to prove that for all functions of for all elements of the codomain, there exists a pre-image in the domain. Now x is equal to y minus 1 by 3. Put y is equal to real number, any real number. This x, the result you will get is what? That is also a real number, right? So this x, y minus 1 whole to the power 1 by 3, belongs to the real number, that is the domain set for all y belongs to the real number set. This is codomain set, codomain 1, right? Now such that f of x, right? X. So x is what? This term. F of y minus 1 to the power 1 by 3, right? Now f of this thing, right? What is f of this thing? X cubed plus 1. So I will obviously write y minus 1 to the power 1 by 3 into cube minus 1, right? Sorry, it's plus 1. Yeah, plus 1. And then y minus 1 plus 1 will get a y, which means we are getting y is equal to f of x. right? So f of x is also onto, is also an onto function. Hence, now again I will ask my viewers to pause the video and then note it down, because we have proved that f is onto function, and hence previously we have proved it that f is also an one-one function. Hence f is bijective, right? Now the second step is write x in terms of y. Now we know that f of x is equal to x cube plus 1, which will imply that y is equal to x cube plus 1. Again, if you solve it, then x is equal to y minus 1 to the power 1 by 3, right? X is equal to y minus 1 to the power 1 by 3. And look, this thing is in terms of y. Now when we write f of x is equal to x cube plus 1, f of x, right? That is within the domain, it's x. Then I am writing this expression is in terms of x. Similarly, this expression is in terms of y. So we can write that x is equal to f inverse of y, right? Generally, so we can write, hence f inverse of y is equal to y minus x to the power 1 by 3. Right? Then just replace this y with another x 1 by 3. Okay, so this is a problem. Now we will see another problem, which is an exponential function when f of x is equal to e to the power x. The steps will be similar. Here it's given that f maps from R to R plus. R plus means the positive real numbers, and f of x is defined as f of x is equal to e to the power x. Now you all should know that e is a positive number, and we have been asked to find out f inverse of x. For finding f inverse of x, what we need to do is that to follow these steps is that we have to prove that f is one onto function, and then we have to find f inverse, right? Okay, so the first step, follow the previous solution. Let x and y belongs to R. Which R? This is this R, right? This one R, the domain one. Then if f of x is equal to f of y, this will imply f of x is equal to f of y. E to the power x is equal to e to the power y. This will imply x is equal to y. So f of x equal to f of y implies that x is equal to y, right? Then we can obviously write that f is one function, right? So one thing is over. Now we have to prove that if this function is onto function or not, right? Onto function. For an onto function, let's say x belongs to R and y is a function that it's an element that belongs to the set R plus, and x belongs to the set R, right? Now we have y is equal to f of x, which also gives y is equal to f of x means e to the power x. Now if we write x in terms of y, then it will be log y to the base e, right? Now, we can see that we have log of y to the base e, that is x is equal to this one, will definitely belong to the domain set real number for all y belongs to the positive real number set R plus. That's why the codomain set here is the positive real number. If this codomain set would have been the negative real number, then this element would not have been belonging to this set, domain set real number. Hence, such that f of log of y to the base e is equals to e to the power log of y to the base e, which will imply you y. That is, we are getting again f of x is equal to y, which is true, we obviously know. Hence, we prove this function f is onto for all x belongs to R. Remember, this R is domain. Don't write R plus, because we are mentioning about R and we are mentioning about this function. So obviously we will mention about the domain set. Now the next step is to find out f inverse. Now that we have proved that this f is 1, 1 and onto, then obviously f is 1, 1 and onto, right? We have proved this thing. Then f inverse exists. Now we are saying that it exists. We have to find out what is the form of this f inverse, right? Let's write the equation y is equal to f of x, which is written as e to the power x. Now, this y is in terms of x. For finding x is in terms of y, right? Notice again, when you are writing expression of x and you are defining this as a function of x, that is, the element is x. Now here, the RHS is having an expression of y. So, we will obviously write this thing as f inverse of y. Again, hence, we find f inverse of y is equal to log of y to the base. Now again, therefore, f log of x to the base e, when x will be belonging to this codomain set. So, after solving this problem, we have come to the end of the video. If you are having some doubts, then you can let us know in the comment section, or you can directly contact us at our email ID, and we are assured that we will respond you within 5 to 10 hours. And also, if you like the videos, then please like, share and subscribe. And we are having other playlists, and if you want to study more, then you can consult to them. Okay, so for today,